try to solve another Leetcode problem 73, set matrix zeros. So for this problem, we are giving m times n integer matrix. So inside of the matrix, it's going to be just integers like 0, 1, 2. As you can see, yeah, it can be positive or negative integers, and it also includes 0. So if an element is 0, set its entire row and column to zeros. So what does that mean? In the first example, so this is a 0, so we're gonna set this one on this column and this row to zeros. As you can see, all those are zeros. Yeah. But we must do it in place. We cannot use the actual memories. So for example, if we use a set, we're gonna use a row set, column set to just to store the positions where 0 is. So for example, if this is a 0, we're gonna store it in a row set and in a column set. But we cannot do that. We have to do it in place. So this means we cannot use a set. Instead, we can use the first row and column to store zeros. So for example, if this is a 0, what we can do? We can store here as a 0, and this is the first row, and for the first column we can store here as a 0. Yeah. So what is the benefit of all this? Is that if we store here, it's gonna have a 0. Here, gonna have a 0, and then we're gonna attack from this position. I mean the second row and second column. So from this position, from here, we're gonna attack. If this is a 0, this is a 0, we're gonna set it to 0. What about here? So if this is a 0 and this is a 0, we're gonna set it to 0. What about this one? If this is a 0, we're gonna set it to 0. And what about this one? The row is 1 and column is 1. We will keep it just as 1. So after that, as we can see, it's gonna always be zeros. Yeah. But there's an edge case. So the edge case is what if? Yeah. The edge case is that what if this number is a 0 itself? Yeah. What are we gonna do? We need to set. If it has a 0, I mean from the beginning, if on this matrix at this position, if it has a 0, we're gonna set the first row to zeros, and similarly for the first column we need to set to zeros. So this means we need to have a tag before we set it to zeros. So we need to tag if the first row has a 0 or the first column has a 0. If it has a 0, so we're gonna set all those to zeros. If the first column has a 0 from beginning, we're gonna set the first column to zeros. Yeah. I think we're gonna use 2 steps. So the first step is we're gonna set zeros to the first row and column, and the second step is that we're gonna tag from the beginning. If the first row has a 0, so we're gonna set the first all elements in the first row to zeros, and similarly to the first column. Yeah. Now we're gonna start. Yeah, we're gonna start solving the problem. So let me prepare row and column. It's gonna be the length of the matrix and the length of the matrix 0. So row 1 has 0. I'm gonna use 2 variables. So how can we check? We're gonna use any elements equal to 0 for this element inside the first row. So it's going to be matrix 0. So this is going to be the first row. Because row and column going to be more than or equal to 1. So this means we can use this kind of a matrix 0 to check the first row. And similarly for the first column, we're going to prepare another variable. It's going to be the column 1 has 0. So here we're going to use matrix with the first column. So it's gonna be R0. So this is gonna be the first column. So for R in range capital R. So this means we're gonna check in the first column if it has an element with equal to 0. So this is the row 1 has 0 and column 1 has 0 check. Yeah. So after that we can start set the first row and column. We can use after that because we already have a check. After that we can use this first row and column as our storage, because we must solve it in place. So this first row and column is gonna be our storage. So for R in range from 1 to capital R, and for C in range from 1 to capital C. So we need to have a check. So if the matrix R and C, if this element equal to 0, so we need to set it. So this means matrix R 0 and matrix 0 C. Yeah, we're gonna set the row and column to zeros. Yeah. So after setting, it is okay. Now we're gonna use the first row and first column to check all other elements. Yeah. So from here, let me just copy this one. Yeah. So the if check gonna be this. So if the first column equal to 0, or the first row equal to 0. Currently, for example, if we are checking this element, if this is a 0 or this is a 0, yeah, we just have that kind of check. Yeah. So if this element equal to 0 or this element equal to 0, so we can set it to 0. So matrix RC gonna equal to 0. Yeah. But this is not the end. After that, we have to check. Yeah, I mean after that we have to check if row 1 has a 0. So we're gonna check all cases. We're gonna set it. Yeah. So this means for the first row, so for C in range capital C, matrix 0 C gonna equal to 0, and similarly we're gonna have the column check. If column 1 has 0, so for R in range capital R, so the matrix R 0, so for all the column are gonna be 0 if it has an element equal to 0. Yeah, right. So we're gonna set it to 0. So as we can see, we didn't use any actual space, so this means it's gonna be in place. And the time complexity, as we can see, there are gonna be 2 for loops, so it's gonna be O n squared at n equal to 200. It means everything should be okay. Let me just submit it to check. Yeah, the first case didn't work. Let me analyze the reason for this. Yeah, so this means I set more zeros. I don't know why, but let me just print out the first row and column to check if there's anything wrong with it. Yeah, I mean the first row and first column should not have zeros, but let me just have check. This is false, this is true. So this means for the first column I check an element with equal to 0, but that is not possible. But let me just have a check. Any matrix RC for R0 for R in range R. Yeah, I don't know why. Let me just print it out here. I mean, for the first row and first column, we should never have zeros according to our first example. Yeah. Yeah, but we get a 0. This is quite strange. Let me have a check. First column, that means it's gonna be the matrix. Yeah, because this is wrong. The R gonna be less matrix. The row gonna be the less matrix. Yeah, so the row gonna be the length of the matrix. The column gonna be matrix 0. Yeah. So this gonna be the first column. Yeah, let me even print out the RNC. It's just very strange. So let me just check the second example. So row gonna be 3 and column gonna be 4. Yeah, row gonna be 3 and column is 4. It is okay. Row is 3 and column is 3 for the first example. So this means our RC is right. Yeah, because here I forgot to check, so this is going to be 0 check. So if matrix RC equal to 0 for R in raised capital R, so it's going to be matrix R0, so it's going to be the first column. Now I think it's going to be okay. Yeah. Now let me just remove it and have a final check. Yeah, because here I forgot to make it equal to 0. Yeah, as you can see, it works. Now let me just submit it to check if it can pass for all testing cases. Yeah, as you can see, it passed for all testing cases and it's pretty fast. So I think the hard part of the problem is that we have to do it in place. If we want to solve it in place, we have to use some extra memories. So the memory going to be first row and column. But before storing any element inside of the first row and column, before storing any zeros inside of the first row and column, we have to check the first row has a 0 or first column has a 0, and finally we have to do the final check. If it has a 0, we're gonna set all the elements to zeros. Yeah. I think that's all about it. Thanks for watching. See you next time.